This is Precalculus section 5.3, day 2 on trigonometric graphs. Periodic functions are sinusoidal curves. The graph has a period that repeats itself over and over again. The period of the parent graph of our sine and cosine functions is 2 pi. Okay, that is a normal period of sine and cosine. So one period occurs from 0 to 2 pi, and then it repeats itself after that. Now, of course, you can change the period of a graph. So if you look at these two equations right here, these show you what the transformed period of an equation will look like. You've got this k value in front of your x. So the period of the transformed graph is going to be equal to 2 pi divided by k. The k value either horizontally stretches or shrinks your graph. If your k value is less than 1, it's going to be a stretch. If your k value is greater than 1, it's going to be a shrink. Now, intuitively, that's kind of backwards of what you would expect, but if you think about it, if your k value is smaller than 1, that means that it's stretching out, or it's kind of slowing down the period. Whereas if your k value is bigger than 1, it's shortening your period, right? It's making the graph happen faster over a period. So let's just take a look at what this does to some graphs here. We've got our first example, y equals sine of 2x. Our k value in this equation is 2. So that means that our period is going to be 2 pi over k, so 2 pi over 2, which means that our period is going to be pi. Now, the first thing I'm going to do is I'm going to graph my parent graph, right? My parent graph of sine, if we recall, it starts at 0, it's at 0 again at pi, it's at 0 again at 2 pi, then at pi over 2, it's up at 1, and at 3 pi over 2, it's down at -1, okay? And then it's halfway here as it goes up, halfway here, halfway here, halfway here. And so again, it doesn't have to be perfect. We just want to get an idea. So that's our parent graph of sine, right? This is the parent. And remember, our picture frame, as we like to call it right now, is from 0 to 2 pi. Well, what we're doing is we're changing our picture frame. So now, since our period is only pi instead of 2 pi, basically our picture frame is going to go from 0 to pi instead of 0 to 2 pi. So now our whole graph has to take place within this window. So you just have to shrink down that curve, and you have to make it happen inside of there. So we're still going to start at 0, we're still going to end at 0, and we're still going to be at 0 in the middle, right? Those are characteristics that never change. But now it's going to be here and here for our halfway. It's going to be up at 1 and up at -1, exactly halfway between there. And so if we just sketch that shape, it's going to look like this, okay? And that's going to represent y equals sine of 2x. So basically what we've done is we've made our picture frame half as wide as the parent. So when we look at our domain and our range, our x values now are in the window from 0 to pi, and our y values are still in the window -1 to +1. So we didn't do anything to change, +1. We didn't do anything to change the height of our graph, right? All we did with this period change is we just changed the width of our graph. All right, let's take a look at our second example, I know it's a little bit cut off here. Our second example is y equals 1/2. That's supposed to be a 2 under there. Y equals 1/2 sine of x. So our k value this time is 1/2, which means that our period is going to be 2 pi divided by k. So 2 pi divided by 1/2 is really 2 pi times 2, which gives us a period of 4 pi. Again, I'm going to graph my parent first. Now notice that my x scale is a little bit different here because we need to accommodate the fact that our period has become twice as big, okay? So the scaling here on our second graph is a little bit different than the scaling on our first graph. So my parent, again, goes from 0 to 2 pi. So here's the start, here's the end, here's the center. And then we're up at 1 in the middle, and we're down at -1 in the middle. And our parent graph looks like this, okay? And again, this is my parent. But now I'm stretching this graph out so that it's going to be twice as long. So here we've got 1 pi, 2 pi. This is going to be 3 pi right here. And this is going to be 4 pi right there. Okay, so now basically our picture frame for our new graph, we're just making it twice as wide. It's going to go all the way out to here. Once you sketch in that frame, you just have to make that shape of your sine graph inside of your frame. So we are at 0 at the start, we are at 0 in the middle, we are at 0 at the end, and then in the first half, we're going to be up at 1 right in the middle, and then the second half of the graph, we're going to be down at -1 right in the middle. Like this. There we go. Sorry. Not quite as round as it should have been there, but you get the idea. Okay, so there's my final graph. And what we've done here on our final graph, you want to just jot this down, is we've made our picture frame twice as wide. So now our domain, our x window, the x part of our picture frame now goes from 0 to 4 pi, and our y value hasn't changed. So that's still from -1 to +1. Okay. We can also shift our graph left or right. So if you see in these equations here, it looks like -b. The b value shifts the graph either left or right. Okay? This is called a phase shift. And moves the picture frame left or right. It's going to shift it to the right if our b value is greater than 0. Okay, so in the equation, an example here might be y equals sine of x minus 4. Now remember, it's x minus the value of b. Okay, so you kind of have to switch the sign there. This means that b would be +4, greater than 0. So it's going to shift it to the right. And then if b is less than 0, an example here would be y equals equals sine of x plus 2, that's going to shift it to the left. So it's what you're normally used to. It looks like it's the opposite of what it actually is. So basically this is going to change our interval. If we have a phase shift, our interval for one period is going to become, our x values are going to shift to whatever b is, and then whatever b plus 2 pi over k is, right? Because our period is 2 pi over k. So we're just shifting our starting point from 0 to b, and we're shifting our end point from 2 pi over k to 2 pi over k plus b. All right, so our next example here, it says find the amplitude, the period, and the phase shift of y equals sine of x minus pi over 3 and sketch its graph, okay? Now our amplitude, we haven't really changed our amplitude yet. The amplitude is just the height of the graph. So A is 1. That just means that the top of our graph is going to be a positive 1 and the bottom of our graph is going to be a negative 1. Our k value for this example is 1, so we're not going to be changing our period. Since we're graphing sine, our period is still going to be 2 pi. Our b value is pi over 3, so we have a phase shift. Our h value here is 0. We will talk more about that later. That's going to move us, up or down, right? Like a vertical shift. Okay? Now, this is really important right here. It says it's a good idea to use the phase shift to determine how to count on the x-axis. You want to make this as easy on yourself as possible. Okay? Hang on, I'm going to fill these in here. So our amplitude is 1, which means we have our normal y values of -1 to +1. Okay? Our period is 2 pi. So that's a normal period. We're not changing our period. But our phase shift is pi over 3. Okay, so what does that mean as far as our graph goes? It's going to move our picture frame. And it's going to move our picture frame right pi over 3 units. Okay, so the x values of our picture frame then, it's going to start at pi over 3, and it's going to end at 2 pi plus pi over 3. So it makes sense for us when we're making our graph here and when we're labeling our x-axis that we want to label by something that makes it easy to count by pi over 3, okay? So if this is 0 here at the start, right, which it is, then I'm going to go by pi over 6s, okay? So my first spot or my first line here would be 1 pi over 6. My second line would be 2 pi over 6, which is pi over 3. My third line would be pi over 2. And then 2 pi over 3. And then 3 pi over 3, which is just pi. And then 4 pi over 3. And then 5 pi over 3. And then 6 pi over 3, which is 2 pi. And then, of course, we need to go another, 2 pi plus pi over 3 here. So here's our new picture frame. Instead of starting at 0 and going to 2 pi, we're just going to start at pi over 3. And we're going to go out to 2 pi over 3. So it's easy if you just figure out where the picture frame goes. Then all you have to do is sketch your sine curve within your picture frame. So now I'm just going to sketch what my sine curve looks like. Starts at 0, 0 in the center, ends at 0, up at 1, and down at -1. And now I can go ahead and sketch my curve. And there's my sine curve.